Hi students, using theories of failure we can solve a problem. So please write this question in your notebook and I can explain how to solve this problem. Write the question. A bolt is designed to take up direct tensile load of 30 kN and a shear load of 16 kN with a factor of safety of 4. The yield strength of the material used is 400 megapascal. Calculate the size of the bolt based on various theories of failure. Take mu is equal to 0.3. So in this question the direct tensile force is given, that is 30 kilonewton. We have to convert this 30 kilonewton into Newton. That means F is equal to 30 kilonewton, that is equal to 30 into 10 raised to 3 Newton. Then shear load is given, that is 16 kilonewton. We can write it as Fs, that is equal to 16 into 10 raised to 3 Newton. Then the factor of safety is given. We can write factor of safety as FOS, or we can denote it as N, that is equal to 4. Then the yield strength of the material is given, that is equal to 400 megapascal. So we can write yield strength as sigma E. Sigma E is equal to 400 megapascal. They are asking about what is the size of the bolt. That means the diameter of the bolt. So we have to find the value of D and coefficient. The value of mu is given, that is equal to 0.3. So write mu is equal to 0.3. These are the given data. Then using this data we can find the axial stress. How we can find axial stress? We know that sigma is equal to F by A, that is force by area. Here the force is given, that is sigma D is the direct tensile stress. So direct tensile load is given, that is equal to 30 into 10 raised to 3 Newton divided by area. Area, here it is a bolt, so the circular cross section is the cross section area is circular in shape. So the area is equal to pi d square divided by 4. Here the d is not given, so we can write the equation sigma d in terms of d, that is equal to 38.2 into 10 raised to 3 megapascal. This equation is generally we know, but if any confusion you can just go through our data book. In our data page number 2, equation number 1.1a, sigma is equal to F by A. Similarly we can find the value of tau. Tau stands for shear stress. What is tau? That is shear load divided by shear area. Here the shear area is same as tensile, that is pi d square divided by 4, and the load is given in the question itself, that is 16 into 10 raised to 3. While we calculating, we will get tau is equal to 20.37 into 10 raised to 3 divided by d square. Here also the value of shear stress in terms of d. That equation is also available in our data book, page number 2, equation number 1.1c. Okay. Then here in the failure theory equation we are using sigma x, sigma y and tau xy likewise. So we have to convert our parameter, that is a given parameter, into in these terms, or we should identify what are the given data in terms of theories of failure. So sigma x, here the sigma x and sigma y is required, but identify sigma x is equal to sigma d, that is equal to given, or we calculated that value. Sigma d is equal to 38.2 into 10 raised to 3 divided by d square. And there is only one directional stress, that is unidirectional stress. There is no sigma y value. Therefore consider sigma y is equal to 0. And we calculated the value of tau, shear stress, that is equal to tau xy, that is 20.37 into 10 raised to 3 divided by d square. Then we can use each theories to find the value of d. First of all, we can take the maximum normal stress theory. What is that maximum normal stress theory? For a safe design, sigma E is equal to sigma x plus sigma y divided by 2 plus root of sigma x minus sigma y divided by 2 whole square plus tau xy whole square. This is sigma E according to normal stress theory. Okay. Then Here the factor of safety, value of factor of safety is given. The factor of safety is substituted in the yield strength, that is sigma E divided by N. Then here all other parameters, sigma X is, we already know, and the sigma Y is equal to 0. Then tau XY is already we calculated. Then using this equation, if we substitute all the values in this equation, the unknown parameter, the only one unknown parameter is d square. So we can use our calculator and find the value of d from this equation. That value will become 21.68 megapascal. Then we can consider another theory, that is maximum shear stress theory. Using this theory, sigma E divided by N is equal to square root of sigma X minus sigma Y whole square plus 4 tau XY square. Here again the value already we calculated, sigma X value and tau X value, sigma Y, that is equal to 0. If we substitute all other values in this equation, we can find the value of d. That value d will become 23.63 megapascal. We can use another theory, that is maximum strain theory. In our data book the values are given, that is in our page 22, equation number 2.8b. Maximum strain theory, sigma E by N is equal to 1 minus mu into sigma X plus sigma Y divided by 2 plus 1 plus mu square root of sigma X minus sigma Y divided by whole square plus tau square XY. Tau XY also, tau XY square. Okay. Here the mu is the another criteria. This value is used only in strain theory, that is given in the data book. Most probably the value will become 0.3. Maximum value will become 0.42. So the mu value is from 0.2 to 0.42. That I can explain, and I can explain later. Please understand, the value of mu is equal to 0.3, that is given in this question itself. Okay. If we substitute all other parameter here, again using this equation we can find the value of d, that is equal to 22.28 megapascal. Then fourth theory, distortion energy theory, or we can call it as von Mises theory. What is that von Mises theory? Again sigma E divided by N is equal to root of sigma X square plus sigma Y square minus sigma X sigma Y plus 3 tau square XY. That we can take from our data book, page number 22 and equation number 2.8d. Okay. Here again all other parameters we calculated. Using this value we can find the value of d, that is equal to 22.80. Okay. Then last theory, strain energy theory. Here also we need the value of mu. In our data book, page number 22, again 2.8e, equation number 2.8e, strain energy theory is explained, that is sigma E is equal to, sigma E by N is equal to root of sigma 1 square plus sigma 2 square minus 2 mu sigma 1 sigma 2. What is sigma 1 and sigma 2? That is the maximum and minimum principal stresses. From the maximum principal stress or from the minimum principal stress, we can substitute all other values in this equation, but we have to find what is maximum and what is minimum principal stress. How we can calculate? Again, that maximum principal stress we can calculate from the data. We can take that equation from the data book, page number 5, equation number 1.8c. What is that? Sigma X plus sigma Y divided by 2 plus root of sigma X minus sigma Y by 2 whole square plus 4 plus tau XY square. So using this equation we can find the sigma 1 value, that is the maximum principal stress. What will be the minimum? That is sigma 2. Sigma 2 we use minus sign instead of plus sign here. So sigma 2 is the minimum. So how will we can identify? Use the minus value here, no other changes. So using this equation we can find the value of sigma 1 and sigma 2. So after finding that sigma 1 and sigma 2, both values will obtain in terms of d. Substitute all other values, that is sigma 1 and sigma 2 plus again there is value of mu is here. Substitute all other values here and find the value of d. Thus we will get d is equal to 22.44. So on the conclusion, we calculate all the values of D, all the values according to the theories of failure. So finally we can conclude like this. According to maximum normal stress theory, the diameter D is equal to 21.68, and according to maximum shear stress theory, 23.63. So according to all other 5 theories, we can write the exact value of the diameter here, and finally we have to convert this value into this one, because the actual diameter we cannot manufacture. We already studied that there is a standard and there are different codes available in the market. So we have to convert our design value into that particular standard. How we can change? Take page number 142. Page number 142 in your data book and table 9.8. What is that? In that table, the standard diameter they are given, and according to that table the size code also given. So 21.68 is not available in the market, so we have to take the upper value, that is next upper value is 24, and it is a bold, so the size will be M24. Next one is 23.63, so just take your data book and consider that value, that is M27. Then similarly we can take all values from the table 9.8, and finally we get 5 values for the bolt diameter. Among this, which one is better? We can conclude like this. Based on above theories, the maximum diameter D is equal to 23.63. That means M27 is the best diameter. All other theories will satisfy in this M27. Okay. Thank you.